In this video, I'd like to illustrate how we can use StatCrunch in order to generate a contingency table or a joint distribution table to summarize the relationship between two categorical variables. So to do that, I'm going to navigate to StatCrunch. I have two categorical variables, namely home ownership and loan purpose. From the values, we can tell that these are two categorical variables. To summarize this data in a tabular format, I would use a contingency table. To generate a contingency table in StatCrunch, I'll head over to Graph, to Stats, and then to Tables. On the tables, I want a contingency table where I have my data or raw data values available. So click on With Data. Then I'm going to choose one of these columns to be my row variable, and the other column will be my column variable. So I'll go ahead, let this be home ownership versus loan purpose, so loan purpose. And in particular, I want percent of total, and I would like it to show the heat map as a quick visualization tool. So I'm going to hit compute, and that should return the contingency table results of home ownership versus loan purpose. So looking through, I can see that the greater proportion or the greatest proportion occurs here at 24%, where you have, so mostly those in this, most of the loan applicants here have what mortgage and debt consolidation. And to see a picture of what's going on here, I can use a mosaic plot, which also doubles as a heat map. And with the heat here, we can tell that there's a lot here, which is where you have the most, concentration of applicants here. This is the way to use StatCrunch to generate a graphical display of the relationship or absence thereof between two categorical variables and a contingency or joint frequency distribution. With that said, let's proceed then to look at more on numerical variables, and that's talking about how to graph one numerical variable. The first graph that is very useful in graphing a numerical variable is a histogram. Here is a picture of a histogram. It differs from a bar plot in that the bars are all smooshed together. They are lined side by side and no gaps are allowed. Whenever I observe a histogram, the first step is to look at the story behind that histogram. So this histogram represents numerical data on the heights of black cherry trees. So, what are the key characteristics of a good histogram? To answer that question, I'm going to look at this example. And in this example, we have data on prices of meal options at Grilling Grub. These are all numerical data. So again, to emphasize, histograms are meant to represent graphically numerical data. Now, which histogram correctly displays the information above? Here are a couple of notes to note about an ideal histogram. Most times it's not perfectly reflecting all of it, all of these characteristics we're about to talk about, but for a greater proportion of the time, we want a histogram that reflects many of these characteristics, if not all. In this case, we can see that we have for 6 to 7, we have what, 7 to 9, then there's a jump to 14 to 15. Something is not accounted for, which is from 10 to about less than 14. In this case, we have a missing gap or interval of data values. So this is not good. So this is not a good representation. Then B, in histogram B, we do have 0 to 6, then 6 to 9. This seems to be a wider interval than this interval. Oftentimes, we don't like that to be the case. So to the best possible extent. We like it when beans or classes or intervals are of the same length. So let me say, or intervals are not of equal width. So in this case, this might not be encouraging. Then we have meal prices at grilling crop. We have a space here that is unused. This is an empty class. So this is an empty bean or interval is not necessary. So this is not necessary, not good. Which leaves us with the last option, which is the good one. 6 to 8, about 8 to what, 10, a little over 11 to 14, and 14 to 17. This meets all the criteria that we're missing in all of the other pieces. This will be a very good histogram. All right, more on histogram. Every graphical display has its own strengths and its own weaknesses. What are some of the weaknesses and strengths of representing a graph, data, using a histogram? Here's an example to illustrate that. This histogram displays the scores of 642 students on a psychology test. The test consisted of 197 items, each graded as correct or incorrect. So we are to use the histogram to answer the following questions. Well, to get a little context, this is histogram on the scores on a psychology test. And the first question here is, what was the lowest score on the exam? This is one of the drawbacks of a histogram. Even though we have the small number here, this might not necessarily be the smallest number. Although we have a range of values that 3 people scored at least 39.5 points and no more than what, 49.5 points, but we cannot tell how many exactly scored the lowest score. Neither can we say the lowest score on the exam. So in this case, individual values cannot be extracted from the histogram in the absence of the raw data. If we don't have the raw data from a histogram. So another way to say that is we do not have sufficient information. However, in question B, we are asked how many students scored between 70 and 80 on the exam. So that would be close right here, and that would be approximately 107 students. So we can extract the count for a range of values, but not an individual set of values. Question C. How many more students scored between 80 and 90 than scored between 70 and 80? Earlier, we saw that those who scored between 70 and 80 were approximately 107 students. But between 80 and 90, between 18 and 90, there will be 147 students. So the difference would be approximately 40 more students scored between 80 and 90 than scored between 70 and 80. Next, we proceed to a guide on what characteristics of data a histogram can show us. The first one is the shape and the spread of the data. So for instance, if I were to draw a histogram for a single numerical data and it has this floating ghost shape, this is said to have a symmetric shape. Otherwise, if it has a longer tail to the left than to the right, it is said to be a left or negatively skewed distribution. And as you might imagine, if it has a longer tail to the right than to the left, then it's said to be right or positively skewed. You see, an example of data set that might be positively skewed is X, the number of divorces among US adults. Among US adults, well, you will notice that small values 0 divorce, 1, 2, 3 divorces. Those are very common. Being very common is indicated by the bump there. So as far as whereas 4, 5, and any more are not as many. So this indicates that a right skew distribution is one in which large values are not very common or not as common as small values. So again, talking about the properties of a histogram that we would observe, one, it shows us the shape of the distribution of our data. And then two, it tells us about the center of the data. How many centers does your data have? Or how many frequently observations does your data tend to show that it has? In the first picture here, we have a single bump up here, and that is a unimodal distribution. This appears to show that we have a bimodal distribution where we have two peaks. In other words, when I see data of this case, I would tend to analyze them in separate what? In separate groups. And then we have an approximately uniform distribution where most of the data values occur with almost similar frequency. Occasionally, a histogram could have more than two peaks, in which case we can say that it is multimodal. Okay. Then another characteristic of data that we see from a histogram is the presence of potential outliers. So if we have any values that appear to stick out or stand out from all other data values, they might be potential outliers. So for instance, if you take data on the personal wealth of Americans, if Bill Gates was one of the experimental or observational units in your sample, then it would certainly be an outlier. Because his wealth will be so typically what atypical, you might want to point out whether this is a special feature or an error or thereabouts. So how do we generate a histogram in StatCrunch? Let's head over to StatCrunch. I'm going to close out of this and look at the data on Danish coffee, consumption of Danish coffee. This is continuous numerical data, and I'd like to draw a histogram or produce a histogram for this data set. So I'll go to Graph, a histogram, click on histogram, and choose the name of the variable you want to graph. In this case, I'd like to put values above the bar so that I can see the numerical counts of the frequencies in each bin. And then possibly, if I want, I might want to see the mean and the median. And in that case, I am going to grab this and move it up and then click on, we're also going to see some other qualities of the graph that I might want. And in particular, click on compute. So I can see that this appears to have a major bump here. So my distribution here would be quantified or typified in terms of the shape. I can say that this is approximately symmetric. It is what? Unimodal. And going back to the picture, do I see any stragglers that are potentially extreme observations? I wouldn't say this is too far off from these observations. So my response is talking about the histogram of the data. It shows that the distribution is symmetric, unimodal, with no extreme outliers. With no extreme outliers. That would be my response.